Students, we're discussing about properties of definite integral. So, so far we have discussed 6 properties. So, these are the property 1, property 2, property 3, property 4, property 5. These we have discussed in the previous lecture. Then, let us find the let us see some examples. So these are examples. We are to do using properties of the integral, definite integral. So number one is, it is integration of 5x minus 3. It is modulus here. The modulus of this 5x minus 3, and it is from 0 to 1. And this one, we see you see this is modulus. So modulus function is actually this one. See, modulus function is so suppose if we say 5x minus 3, this modulus. So what is our function? 5x minus 3 from 0 to 1. So x is lying between 0 and 1. So let us see 5x 0. So 5x minus 3, it is x is lying between 0 and 1. So when you say positive, so 5x minus 3, it is greater than 0. So 5x minus 3 is greater than 0 if what? X is greater than 5 by 3. X is greater than 3 by 5. So when x is greater than 3 by 5, then it is 5 goes, it is 0. So this is equal to, so when x is equal to 3 by 5, then this is equal to 0. And this x is, so this is when x is greater than 3 by 5 and less than 1, then it is positive. And negative when x is, so when x is less than this 3 by 5, then this is negative. And that is why we have to take two parts here. Two parts you consider. Two parts we consider, and one is, so we take, so this is x. So this one is 0. This is 1. So 3 by 5. 3 by 5 is it is less than half, greater than half. Sorry. So greater than half. So it is 3 by 5 is somewhere here. You take 5 parts and it is 3. So when x is greater than, so for this x 5x minus 3 greater than 0. And for this part, this is less than 5x, but because we are considering 5 modulus part, 5x minus 3, and that this is always greater than 0, and that is why when this is less than 0, we write y is equal to, or fx is equal to minus, we consider negative part, minus 5x minus 3 for this part. So this fx, this part, we consider this one. Means what? Suppose x is equal to half. Suppose x is equal to half. Then x is equal to half. Then this becomes 5 by 2 minus 3. So 5 by 2 minus 3, it is again half. So for this, a half is here. So for half, our value is half, because we are considering the modulus part. If we write half here, so if we write half here, then 5 by 2 minus 3, it is minus half. So minus of minus half, it is plus half. So we are dividing this domain. So one part is 0, lower part is 0. Then we stop this one at 3 by 5, and then we go again start for this journey. So for this, our function, we are considering this one different and this one is different. Now we are using this property. We will use, it is a property, applying property 3. So applying property 3, in property 3, what we had in property 3. In property 3, we had a to b, so 0 to 3 by 5. So our function mod of fx minus 3, so it is minus of 5x minus 3 dx. So this is the integration. We are applying property 3, and then from 3 by 5 to 1, our value is 5x minus 3 then dx. So this is, we are using this property, and it is property 3. So this is the example. So 5x minus 3, this part is, our value is, the definite integral, we'll do it like this. We integrate, it is 3x, this is 5x square minus x square by 2, this one. So our value is this, we are adding it, ultimately we get the result 13 by 10. So this is number 1. Number 2 is similar. Number 2 is similar. It is integration of, it is again modulus cos x, x lying between 0 and pi. So what is our cosine graph? Do you remember what is our cosine graph? You can, if you draw it, then it is easy. So cosine graph is, this is our domain is in 0 to pi. So 0 to pi, this is 0, this is pi, this is pi by 2. So x is at x equal to 0, it is 1. So this is 1, say. And x at x equal to pi by 2, it is 0. So this is our graph. Cos pi, it is again minus 1. So this is our cosine graph. And you see, we need modulus of cos x. That is why we have to integrate this one. So you see, this part, in this part, it is negative, cos x is negative. So these are, it is y, it is negative, minus, it is minus value. So you consider reflection here. So you consider reflection here. Actually our graph is this one, mod of cos x. So you erase it. You erase this one. So actually this is our graph. So we need this. But our it is cos x. So you have to write this cos x. So you take two value, one value here, pi by 2, and this is pi. So for this it is cos x, and for this it is minus cos x. So say this example, it is 0 to pi by 2 cos x dx, and it's pi by 2 to pi minus cos x dx. So it is as a fundamental theorem differential calculus. It is this one. Yes. So this is the next one, is next problem. It is number 3. It is again modulus value. So modulus value minus 5 to 5. So x minus 3. So x minus 3, x is lying between minus 5 and 5. So minus 5 and 5, y is equal to x minus 3. So x minus 3 is positive when x is greater than 3. And that is why our domain is this one. Domain is minus 5 to 5. So this is our value. It is minus 5. This is 0. This is 0, say 0, and this is plus 5. This is plus 5. So if you draw the graph, how will you get it? X minus 3. So y is equal to x minus 3. X minus 3 means x is positive when x is greater than 3. So if it is 0, then 3 is here, 3 is here. So when x is equal to 3, y is 0, and when x is equal to when x is equal to 0, x is equal to 0, then it is minus 3. So our graph is this one. It is a straight line graph. So if you draw this, we will have like this. And this one is, so this is negative here, and that is why you consider the reflection of this. You consider, so this is negative. We need, because it is modulus, so we need this value. So this one. So this graph we require. So you don't need this one. You erase this one. You don't need it. Means what? Our domain is from minus 5 to z. This is 0, this is 3, and this is 5. So you consider two parts. For this value you consider minus of x minus 3, and for this value you consider x minus 3. And see here, so for minus 5 to 3, our integration is this one, 3 minus x minus 3, negative of x minus 3 is 3 minus x. And for lying between 3 and 5, our value is this one. So we are doing this one, and it is 9 plus 25, value is 34. Next, see this problem number 4. In this problem we are applying property 4. So that property 4, what was that? Property 4, you can see here, property 4. See this one. So a to b fx dx, its value is, this is equal, a to b fx dx is a to b f of these two limits, lower limit and upper limit. You add them, a plus b, then minus x. So they are same. So here you apply this one, number 4. So here a is 0, b is pi by 2. So cot, our example is this one. So our example is this one. This cot x, we write it as cos x by sin x. So cos x by sin x, and when you simplify this one, it is this one. So it is this is cot x. Cot x means cos x by sin x. Cos x by sin x. So when we write 1 by 1 plus root over cos x by sin x, and after simplification you can make it this root over sin x, you multiply this is then root over sin x plus multiply root over sin x here, and this goes, it is root over cos x, and numerator is again root over sin x. And this we are doing here. So this is root over cot x, we are writing like this, root over sin x divided by root over sin x plus root over cos x. So it is done. Then we are applying property 4. So property 4, it is root over sin x, then root over sin x. So is a plus b. So 0 plus pi by 2 minus x. So it is pi by 2 minus x. This is pi by 2 minus x, pi by 2 minus x using property 4. Then this cos of pi by 2 minus x, this becomes sin x. This is cos x, this is cos x, this is sin x. Again we are having the same value. Not same value, sorry. The denominator is same. Denominator is same, but numerator is different. The numerator is here is root over sin x, and here it is root over cos x. But they are equal. So starting from this, we get again these two values. These two values are equal. Now you write 2i. 2i means what? I plus I. So one I you write this one, and other I you write this one. So this is I plus I, 2i. And after adding, we are getting numerator, it becomes equal to denominator. And cancel it out. This goes, and this becomes only root over. This will go, and this is 1. Cancel out. So it is 1. So it is only integration dx. And it is x, value is x only, x from 0 to pi by 2. This becomes a value pi by 2. Means what? Twice I, value of twice I is pi by 2. Value of twice I, this is equal to pi by 2. Therefore, I is equal to pi by 4. So this is number 4. And 5, this is also same value. Here it is, a is pi by 6, property 4 we are applying. It is pi by 6, it is pi by 3. Then integration of this one. So we apply property this one, pi by a plus b minus x, a plus b minus x. Ultimately, this becomes like the previous one. So this expression is same. Root over sin x by root over cos x plus y. This one, root over sin x by root over sin x plus cos x. Only limit is different. So limit is different, and this again becomes root over cos x, root over sin x. They are same. Again we are doing like same procedure. Twice I is, we are adding this 2, then this becomes integration of dx. So integration of dx here, pi by 3 minus pi by 6. So pi by 3 minus pi by 6 is pi by 12. Pi by 6, pi by 6. Pi by 3 minus pi by 6 is pi by 6. So I is, you divide by 2, I becomes pi by 12. So this is our problem 5. 6 is also same. Yeah, here no square root sign here. No square root sign is here. So this is same. Same property 4 we are applying. Number 6. And here also we are applying property 4. Okay. Property 4, it is log of tan of pi by 2 minus x. This property 4. This is minus, and here you see cot tan, here it is tan of pi by 2 minus x, it is cot x, but cot x you can write as 1 by tan x, and 1 by tan x means reciprocal of tan x. Reciprocal of tan x, when you take the logarithm, then this minus sign comes here. So minus sign come here, so this becomes log of tan x, and then you add this to I plus I. So this is also I, this is also I, same value, but one is negative of this, and then you make add this to, you will get. So take this to left hand side, this twice side, this becomes 0. So I, value of I is 0. And number 8 is also same procedure. It is also same. Here is there is some calculation here. You can try it. We'll discuss in the next video. Calculations are there somehow. 1 minus cot x. We'll do it later. So for today, this much is done. So thank you.